Hey guys, welcome back. We're going to do problem from chapter 14, number 108. So there's a proposed mechanism for the formation of hydrogen iodide, which of course is HI. Right? And what are the reactants? Well, it looks like we got I2 and H2. How do I know that? Well, I doesn't exist by itself because it's one of your 7 diatomics, so it has to be I2. H2I probably doesn't exist by itself because H2I kind of doesn't, we've never done that before. And H2I is an intermediate, except for since you see it made here. So how do I know? I start with reactants. So look at the reactants. We know H2 is a reactant because we start with it. Also, H2 is a reactant. We know why, because it's a diatomic molecule that exists. I is an intermediate. So if I highlight the intermediates in yellow, intermediate, I is an intermediate. So H2I is produced, intermediate, 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 and then finally the product is 2HI. Perfect. Now, if you notice slow here, that's our slow step. If we go back to our equation, I would have H2 plus I2 going to H2HI, looks like. So the rate law has to be something of rate is equal K, concentration H2 to something, and I2 to something. So whether we call it P and Q, whether it's R and S, A and B, doesn't matter, X and Y, those are the exponents. So that's the rate law. However, we have these fast steps in equilibrium and the slow step. So we know that the rate law comes from the slow step. So currently, our rate law would be rate equals K5 times the concentration of H2I times the concentration of I. So what I need to do is substitute in for H2I and I to get the rate law in terms of H2 and I2. So let's write them all out to start. So we start, and I'll use colors for us. Rate equals K1 times the concentration of I2, and rate equals K2, lowercase k, K2 times the concentration of I squared for the first one. For the second step, we got rate equals K3, concentration of I times concentration of H2, and rate equals K4 times the concentration of H2I. So we have the forward reactions and the reverse reactions. So I'm going to write down forward and the reverse. Now, this rate will equal this rate. Those rates are the same. And this rate equals this rate. So what I can do is have K1 times concentration of I2 equals K2 times concentration of I squared. And orange equals orange. So K3 times concentration of I and H2 equals K4 times the concentration of H2I. So my intermediates, if I get back in yellow, every intermediate, I is an intermediate, I is an intermediate, H2I is an intermediate, H2I is an intermediate, and I is an intermediate. The reactants that we're looking for are I2 and H2. So what I need to do is solve for these intermediates here. So now the first one I'm going to do is solve for H2I. So I'm going to use the orange here, these guys, and come up with something for H2I. So just doing algebra, I can divide both sides by K4. So the concentration of H2I will be equal to K3 times concentration of I times concentration of H2 all over K4. Perfect. So now I can substitute all of this right here. All of this can go for H2I. So I'm rewriting the rate, and we'll make it red for the overall rate. Rate is going to be now K5 times all this in orange for H2I. So that would be K3 I H2 all over K4 times concentration of I. So now this is where it's going to be tricky, because if we look at up here in purple, in the purple box, I have I squared and I2. I need to get I2. So if I solve for I squared down here, concentration of I squared equals K1 times I2 all over K2. Well, if we look at this now over here with the red rate, I in orange times I in black is going to be what? I squared. So let's rewrite this. Rate, I don't want it red. Rate will be equal to K5 times K3 times concentration of H2 times concentration of I squared all over K4. So now I can substitute in purple here for I2. So then we get rate equals K5 times K3 times concentration of H2 times K1 times concentration of I2 all over K4 times K2. And so rewriting it nice and neat, rate is equal to K5 times K3 divided by times K1. That's capital K. K1 all over K4 times K2. Now, it doesn't matter. A lot of times they'll write in numerical order. It doesn't matter. But then we got concentration of H2 times concentration of I2. Ultimately, all of this becomes just K. So all of this just becomes the measured rate constant. So you get rate equals rate constant K times concentration of H2 to the first power, I2 to the first power. So that's how you get the rate law. The red one's probably the answer for the problem with all the different K's, but ultimately it's just K. We get measure one rate constant. So hopefully that helps with problem 108. Take care.